Elouise and I'm part of the Maths department here at the University of Wolverhampton. Welcome to this video on Essential Maths for Chemistry. So this video will be going through uncertainty, standard form and logs. Uncertainty gives you the range of measurement in which a true measurement lies. So it's usually half the smallest division that an equipment can measure in either direction, because you can't be sure if it was up or down from where the little line is on the measurement. So if we measured 5.2 centimetres on a burette and it had markings every 0.1 centimetres cubed, the volume reading would be 5.2 plus or minus 0.05 centimetres cubed, because you can't be sure. So it could either be 5.25 centimetres cubed or 5.15 centimetres cubed in actuality, or any range between. So we might want to calculate the percentage of uncertainty is, and we do that by doing uncertainty divided by reading times by 100. For example, if we had an EMF reading of 0.86 volts and the voltmeter's error is plus or minus 0.02 volts, the percentage uncertainty would be 0.02, which is the uncertainty error given, divided by 0.86, which is the reading, and then multiplied by 100 to make it into a percentage, would be 2.3. So the reading is accurate within plus or minus 2.3%. Standard form is used a lot in chemistry because it can show either really, really big numbers or really, really small numbers without having to write them all out. So they're in the form a multiplied by 10 to the n, where a is a number between 1 and 10, but it's not 10. If it's a positive n, it means multiply a by 10 this many times. If it's a negative n, it means divide a by 10 this many times. So for example, if we had 7.82 times 10 to the 4, it means the actual number we're after is 7.82 multiplied by 10 4 times. So I like to draw it out by jumping with the decimal point. So let's put loads of zeros after, because as we know, if we have loads of zeros after a decimal point, it doesn't matter. And let's move that decimal point to the right 4 times to signify that we're multiplying by 10 4 times. So 1 jump, 2 jump, 3 jump, 4 jump. Our decimal point ends up after the end of that 0. So 7.82 times 10 to the 4 is 78,200. And again, if it was to the negative 4, it would mean that we want to divide that number by 10 4 times. So we can have as many zeros in front of a 7 as we want, and it's not going to change the value of the number. And then we're going to move that decimal point to signify dividing by 10 4 times. So 1 jump, 2 jump, 3 jump, 4 jump. And that's where the decimal place ends up. So 0.000782. Now these will probably show up on a calculator if you just did 7.82 divided by 10 4 times. But when we get to really, really big numbers and really, really small numbers, your calculator doesn't like it. So it's really important to know how to use standard form. Another really important thing to know how to use in chemistry is logs. So logs are the opposite of powers. If you had 10 to the power of x equals y, well, the opposite of that would be log to the base 10 of y equals x. So this is known as the base 10, with log and then 10 at the bottom there. Sometimes it's just written as log y, and if you see just log y, we do mean to the base 10, because there are other bases we could use, either any number, 2, 4, 7, whatever you want, or in a special case, if we have the base e, that's known as a natural log. So logs are used within the pH scale. So to work out the pH, you have pH equals minus log to the base 10 of hydrogen ions. So if we wanted to calculate the pH of a substance with 0.3 mole per decimeter cubed hydrogen ion concentration, how would we do that? Well, let's get that handy formula up. And we know what the hydrogen ion concentration is. That's that little H plus inside the brackets there. So in our calculator, we write minus log to the base 10, which on your calculator will just be a log button. of 0.13 and we get a pH of 0.89. If we wanted to go the opposite way round and we were given a pH and we wanted to know the concentration of hydrogen ions, how would we do that? Well, here's the equation we got given. Okay, so first of all, let's get rid of the minus in front of the log. We'll take away that negative. And then how do we go from here? Well, as I said, powers are the opposite of logs. So to get rid of a log to the base 10, you do 10 to the power to both sides. So 10 to the minus pH is H+, which is the concentration of hydrogen ions. Again, it's a little bit complicated. It involves a lot of algebra skills, so just keep going over it. Make sure you really brush up on these. But now we know what we can do. We can do 10 to the minus pH, which we have 7.8, and that gives us our concentration of hydrogen ions, which again is in standard form, which is why it's really important to know how to use standard form and know what standard form means. And don't forget your units, moles per decimeters cubed. So that concludes our video on essential maths for chemistry. Hopefully you found it useful and hopefully you'll check out some of the other videos we have in the series.